Alright, number 4. They call this the reciprocal function or the rational function. Why is it reciprocal? You can flip that and you get y equals x, which is a linear. Alright, so domain goes in which direction, class? Well, let's get a graph in there. So if you put that into your calculator, now because there's nothing in the numerator or denominator, you don't have to use parentheses, but normally I would. Some of you need to do that because you guys are getting the wrong graphs. Zoom 6. Sketch that graph. We just kind of did one very similar during the warm-up. Domain means which direction? Left to right. As I go from left to right, what's happening there? I have an arrow, so that's from negative infinity. Parentheses always with infinity or negative. And then I have to stop here, right? Does the graph go here at 0? No. Don't include 0, that's why it's a parentheses. It's going to be in union with. Starting here, it's 0, but you're not touching 0. That's a parentheses to infinity. So that's our domain. Basically, on the x value, you can pick any number except for 0. Class, range is which direction? Range? Bottom to top. It's essentially the same thing, right? What's the only number we can't pick? 0. So I'm just going to copy the same thing. From way down here, I can pick any number, negative number up to 0. Don't include 0. That's why it's a parentheses. Does anyone know another name for roots? X-intercepts. Question. Does a graph have any x-intercepts? None. How about y-intercept? Is it ever going to touch the y-axis there? No. None. Okay. Where is it increasing? That's going from left to right, right? The roller coaster? Is it ever increasing? Nope. So you write none. How about decreasing? Yeah, from here. From negative infinity to where? 0. So now I'm looking, just what I'm writing down for increasing, decreasing is the x values, but I look at the y values. Does that make sense? So if you want to write you're going from decreasing, is it just goes down. So from negative infinity to 0, it's decreasing. And then from 0 to positive infinity, okay, that's positive infinity. So essentially the same thing you have up there. Class, continuous or discontinuous?
Discontinuous.
So is it continuous?
No.
No. You can write discontinuous infinite was the answer from the test quiz. Okay, this one's talking about its symmetry. So is it symmetrical about the y-axis? Can I just flip it over? No. How about odd? Is it symmetrical about the origin? Yeah, so this would be odd symmetry. How about extreme? What are extremas? What are some words that you're used to? Minimum, maximum, local, and absolute. Do we have any? No, because there's no peaks in the mountain. Does that make sense? There's no turning there. So for extremas, there's actually none for this one. Is this bounded? Do I have lots of boundaries there? No, because the arrows tell us you can keep going, so none. Or no, it's not bounded. Vertical asymptotes? Yeah, x can't be what? 0. And you also have a horizontal asymptote at y equals 0. Okay. End behavior. Remember, don't be scared of the word limit. We just talked about end behavior. As x approaches negative infinity, so as I go in this direction, where's the graph going towards? Can I pick any number here? Can it go up here? Can it go down here? No. The horizontal asymptote tells us there's kind of like a boundary, right? Can you drive on the other side of the lane? No, so it's approaching what number?
0.
On the y value is 0. And as I go towards the right, this graph now, right? Where is it going towards? Also 0. So you can read it as x approaches negative infinity, f of x approaches 0, and as x approaches positive infinity, f of x approaches 0.